Welcome, welcome, welcome. Go for it. Leave me a seat. All right, guys, come on, file in, fill up all the seats. All right, come on, y'all. Let's get this going. All right, all right. I think we got almost everybody in the room. Can I have some quiet, please? I am not going to compete with you. I am just recovering from a cold, and I'm trying to take care of my voice. Welcome to Berkeley once again. Did you guys enjoy your picture? You came on a very beautiful morning. It's so serene. It's like experiencing a piece of mindfulness. And it's this mindfulness that allows all this creativity to come up. You guys are starting off the morning here with a bang. You guys are going, the very first thing you're going to see is the UC Berkeley graphics group. They call themselves are you UCBUGG?
UCBUGG.
Yeah, UCBUGG. They do all the animations, and some of them are future Pixar or Industrial Light and Magic folks. They're going to show you some of the animations, and they're going to show you some of the processes that they use in doing this animation. I hope you guys are going to enjoy it, but before I go into that, how many of you guys have seen Coco? Is it called Coco? Isn't it called Coco? Okay. Should I watch it? I haven't. For real? Like.
Hell yeah.
All right. Should I watch Coco?
Hell yeah.
I was already done. I think I was just like over the. The only thing I'm interested in is Incredibles 2. We have waited 13 years for this. I am pissed by one thing though. They are still kids. Jack is still a baby after 13 years. All right. Veronica?
Yes. Veronica, yes.
Oh, Veronica. All right.
Yeah, cool.
I've gassed them up for you.
Thank you. Hi, everyone. Hi. So, as you know, we are UCBUGG, which stands for UC Berkeley Undergraduate Graphics Group. And what we are on campus is essentially what's called a decal here, which is basically we're students who teach other students some stuff that we're really passionate about. So I know you guys have seen, hopefully, Toy Story, or, yeah, The Incredibles, and some of you, Coco. Come on. Watch Coco. It's great. But anyway, we teach students to create a 3D animated film. So students get into groups of like 5 people. And by the end of the semester, they get to create these really beautiful, really awesome 3D animated films, similar to Incredibles or Coco, but just in a shorter length. Yeah? So what we want to emphasize for today is that filmmaking isn't necessarily super simple. It's kind of complex. It goes into like this huge pipeline that you can definitely break down to. So what we're going to be talking about today is actually breaking these little things down so that hopefully the next time you go watch Coco or Incredibles 2 in the future, you get to kind of pick out these little artistic aspects and really enjoy them and tell your mom, hey, I really love the shading in that, and then she'll be like, what? But you don't know what you're talking about. So Ellie's going to be starting with talking about pre-production and story in film.
Hi, I'm Ellie, and pre-production is basically what we do before we start the cool stuff like modeling and animating. So because we're all storytellers here, we start with a story. So let's say I want to have a story about some raccoons, and because they're all shady and sneaky, I want them to steal something. So they're gonna steal a key that is owned by a cat. So in order to visualize what that's going to look like later, I'm going to make an animatic, which is basically a bunch of pictures that we put together in a video, and it basically tells the story. Okay, awesome. So now we know what our character's motivations are, we know what the background looks like, kind of, and now we can start with designing characters. Now this is a character turnaround. As you can see that we can see all three sides of each character because we need it for modeling in 3D. So now we're gonna be modeling in 3D with Rachel and Ricky.
Hello. So in a 3D movie, we need like props that are in 3D. So say we want to make a staircase. How would we start? Rachel's going to create a cube because we always start out with cubes and just build up from there. So the great thing about working in this program called Maya is that we can stretch and adjust our shape as we see fit. And say we, like I mentioned, want to make a staircase. How do we go about doing that? What was that? Close, but no. Like I said, we only start off with the one cube. So now we made a bunch of faces on top of this, I guess, rectangular thing now. What Rachel has to do now is to select faces and do this process called extruding. That basically means selecting a face and extruding it out so you make more volume. Crazy, right? And we keep going down, decrementing as we go, and then eventually we'll have a staircase. And now we have a staircase. But you're probably thinking to yourself, that's simple. I want to see a character. How would we do that? It's a lot more complicated, so we're going to fast forward to a raccoon model we already have. We actually can make this character a little more buff through this sculpting process. So anyone familiar with like sculpting clay? Yeah, we can actually do this process here via the sculpting tool. So if Rachel were to start, I guess, wanting to mess with the tail, she could. And she can make the raccoon thicker in other areas of its body. Everyone get the idea? And now you notice that this raccoon has some kind of like a skin to it. You may want to add more materials to objects, like say making it look like rubber or glass. And we do that through this. Wait, are we doing animation? Shading?
Oh, animation.
Oh, I lied. So you know how characters move? Yeah, that's sorry. We can actually animate our models through like animation.
All right. So how many of you guys have done stop motion? Stop motion or claymation? Cool. All right. So it's similar to that. If you notice, we have these multicolored lines. These are our skeleton for our model, similar to a wireframe for a clay motion sort of character. This helps us define how our character can actually move in a 3D space. So if you notice here, Arthur is clicking on these circles, and these are our controllers. So similar to a marionette and how you can control it using lines of sorts, we can use the circles to move around our character. So similar to stop motion, how we can take pictures for every single frame, along this timeline here, we have all of our frames, and these red tickers are where we save the position of our character, similar to taking kind of like a screenshot with our camera. So notice here that Arthur is saving these points of our character. So similar to maybe like, if I start here, I can save that, and then if I have my hand up, I can save that next position, and the computer will automatically go between those positions and fill it in. So my hand would go up like this in the actual video. Yeah, so it does take some time, but we save all of these different positions, and when we play through our timeline, we can kind of see what's going to happen. Right now, we're trying to model it so that he's going to be waving at the audience. Yeah, so that's a small glimpse of animation. All right, so now we're going to be doing shading. Usually for model, as you see with the staircase, it's all gray, but you probably don't want an entire short of just gray walls and gray characters, unless that was an artistic statement. But here we have our car, and similar to, I'm going to use the clay analogy again, we want to do these things called shaders, and shaders help us define the color, the feel, and the texture of our entire model. So here we have our tour car, and Rachel is going to select different parts of our model, and then we can assign these to new shaders that we create. So first we're going to give a metallic look to our rims of our car. And we're using Renderman, which is a Pixar created software that has some pretty nice shaders. So in our attribute editor, as you can see on the right over here, we can edit the different settings of our material, and in this case, we're trying to mimic the look of metal. So we've got many different things. We've got color, but the important thing for this is specular, which is another word for, in our case, making it shiny, because you probably want the metal to look pretty shiny. And yeah, now we're going to select the wheels and the interior of the car, and we're going to give it a sort of black rubbery material. And the nice thing is, in Maya, you can select different things at the same time and have them all have the same shader. That lets you save time. You can also later on use the same shader for other objects. Great. Now we're going to make the rest of the car a hot, fiery red. There we go. Yeah. Great. So now we have our toy car, and we're going to render it. And rendering is essentially letting the computer generate a frame that we would actually see if we were to make the final video. Right, so now we have our shaded car. But notice, we can't really see the stuff we want to, and that's because we don't have lights. And so that's our segue into lighting.
So lighting is like super important when in like film and theater productions, and it's as important here because it makes it so that we can set the mood and so that we can actually see all of the shaders that we just put in. So right now, Ricky is just he put in a plane on the bottom just so we can have some more dimensions. And now he's gonna be putting in some lights. So now we're rendering again. And as you can see with the lights that he put in, this process is going to take a while just because the computer is calculating like how the mesh, how the shaders, and how the lights all work together, so it can tell you how it actually looks. But yeah, that's what our car looks like right now with the lights like bouncing off the red paint material that Rachel put in. So now to make the car a little more cooler, we're gonna add in some effects.
Okay, so anytime you want to create smoke, fire, water, that's basically, you're going to tell the computer to simulate real life physics. So make a digital object behave as if it existed in real life. So that's what we're going to do here. We're going to create smoke coming out from the tail end of the motorbike. So hopefully it'll look a little more realistic, like it's running in real life. So first what we have to do is we have to create a box for the simulation to take place inside so that no particles can go outside of this box. Basically, it saves us a lot of computation time so our computers don't have to run overnight and all that kind of stuff. So you can see right here the particles are emitting from this little point in the center of the screen, but we want them to come from the tailpipe of the motorbike. So what we have to do is move that little dot in space to the end of the motorbike. So first we gotta select it, that's a big thing. And then we just move it to the end of the motorbike. And if we run the simulation now, you'll see that smoke is actually coming from the tail end. But you'll notice if you're riding a motorbike, the smoke's not just going straight up, it's going out because the motorbike's moving forward. So what we have to do now is create what we call an airfield. So create wind that's going against the motorbike to push the particles backwards. So what we do here, made an airfield, and then we have to change the direction of the airfield so that the computer knows what direction the particles are going to go. And we also might have to change the intensity of the airfield that it actually pushes the particles. And as you know, smoke in real life is made up of little tiny particles, and you can just see them as smoke with your eyes. So that's basically what the computer is doing here. Now you can see, since we changed the intensity of the wind, the particles are actually going out the back of the motorbike. So this is a good intro to effects.
So now that we have basically everything done, what we're going to be doing at the very end of your film is the thing called rendering that I think a few of us mentioned, where basically you take all the lights, all the colors, all your models, and put them all together into the computer, and it kind of translates all of this into one single image. Of course, your film is going to be kind of moving, so you're going to have a bunch of different images per frame. or actually you're going to have one image per frame, sorry, and then you're actually going to put together all these images into a video editor such as like Premiere or Final Cut Pro. Maybe some of you are familiar with this, yeah? And then you put them all together, put in sound effects, stuff like that, and then you get your final film, which I will show you now. So hopefully this gives you a better idea of what to look out for when you're watching your animated films, but this is the end of our presentation. So we'd like to open up the floor for any questions or comments, or we can also show more films as well. There's a question there. There's also games, yeah, and there's also VR and AR, which is like emerging technologies, right? Yeah. Yeah. This took a year for 30 seconds. With like 12 people. Coco took 6 years. So watch Coco. Yeah. We have 20. Oh, 12 people. Yeah. There's a question there. Sorry, can we get quiet in the audience a bit so we can hear questions? Thanks. Yeah. I think variable times, yeah. I took like 4 years. We're still learning. Yeah, we're still learning. Yeah. Yeah. Are there any other questions, or we could show films? Yeah, in the back. This specific film? This took a year, including the ideas. Yeah. It's a long process. Yeah. Well, our decal doesn't teach you how to make games. However, with the program like Maya, you can definitely create like models and everything within Maya and then transfer it into a different program to create your games, yeah? But Maya, you can definitely create your entire film in this one program, which is insane. But yeah, right there. Right. I think, I'm not sure about this film, but like for other instances, I know it took hours, like a semester at least, like like a few months. Because you have to keep refining and refining and refining, because things don't always look perfect to you, right? Yeah. Are there any other questions? We could show films, or, yeah, in the back there. So we don't use Final Cut Pro for rendering. We use it for editing. For editing. So within Maya, you would be rendering. Then you would get those outputted rendered images and then put them into a different program. That's for editing. Yeah? Does that make sense? Yeah. Cool. Okay, so I think we have 10 minutes left, so we could just show films. Yeah? Cool. Wait, we had one more question, I guess?
What do I do? I like to do lighting for 3D movies and make music for it, so. I didn't work on this short, actually. Yeah. I did, sorry. Just me. Oh, question right here?
You won't. It's a mystery.
It's up to you.
Yeah.
You wanted to know what was in the box?
Cool. So we're going to start showing films. So
Who's my Maya? Yeah, or it's in the queue. Is that about time? One more? Final one. It's the best CNN.
No. No.
So I'm gonna unplug.
All right. So you guys give them a round of applause. And now we're gonna have CS10 projects. CS10 projects, are you guys here? Where are they? Come on. Any outstanding questions while the other team sets up? How do you guys feel about that, watching those shorts? Hey. You know, I think Horsepower, the last short you watched, I think it actually won an award in competition. That last short, the one with the girl, come on in. It actually won an award in competition. So these are students who probably 12 to 16 months ago were in high school. Is that fair to say? Is that correct? So they are fairly new to Berkeley. They are freshman students in our class, CS10, The Beauty and Joy of Computing. And they're going to show you some of their final projects. Take it away. Oh, wait, no? Yeah?
We're trying to, okay, yeah. I got you.
So,
Okay. Do you need audio? Yeah. I don't know if it'll like be really loud though, if it's like all the way.
You can start talking.
Okay. Well,
Is there audio.
Okay, so hi, my name is Kachi. I'm a freshman at Berkeley, so I'm pretty much just ending my first semester here. And I'm from Richmond, if we have any Richmond people here. Like, okay, I see you guys, yeah.
No.
So, yeah, like, I'm in Beauty and Joy of Computing, also known as CS10, and I pretty much did my final project on this Street Fighter game. So I call it, like, Street Fighter, but Snap Edition. So, like, yeah, it's really cool. I'm gonna show it to you guys. Let me just, I was playing it before, so like that's why it looks like this. Okay, so yeah, this is just like the menu screen. And so I pretty much made 2 game modes because I had to do it for my midterm and my final project. So the 2-player versus mode is like if you have a friend to play with you, you guys just, you know, like your typical battle game, like 1v1. But the one that really took a lot of time was the 1-player versus CPU mode. So you're playing against a computer, so I'm gonna show you guys that one because that one was pretty difficult. I don't know if you guys can hear it, but yeah. So yeah, you just like pretty much play against the computer that I made. Like he's programmed to know like when to come close to you, like how to fight, how to like block and everything. And like he's really hard to defeat, so I'm probably gonna end up losing at the end. But like yeah, like he's pretty cool. And I'm pretty much waiting for, so like I also did like a little itemization drop. So like there's like a health kit that he could get, and like, you know, the itemization drop, it pretty much drops things like the power-ups, so you can activate your super move or like special move, and like one that diminishes your health and everything. And yeah, so like this is just pretty much like AI, and like in the end, like if I lose, you know, he does this little like dramatic fatality pose, and like he ends up dead, and then yeah, it goes to that. So yeah, he pretty much beat me really bad, but like, yeah. Yeah, so for the code, like, pretty much there's like multiple different sprites. The key thing is like the sprites, because you see there's like a ton of things happening. So like you have to program each and every one to like do a certain thing. And like, even within like these blocks, there's like blocks that tell it what to do and everything, like if you click edit and stuff. But it's pretty much, it has to do with like broadcasting. So like you're telling one sprite, oh, do this at this certain time. So like when you saw the itemization, like the thing dropping, like it was told to do that at a certain time, like when the health hit a certain point. And so like, even with this, like Snap has so many different cool things that you can do with it. I tried to do like a thing where I would create a controller using like this thing called Arduino. So you're kind of putting engineering into it. So like instead of, you know, like with the computer, you guys, like if you're playing with a friend, you're squished onto like a keyboard. With Arduino, you can just like program your own like homemade controller. And so like you guys have like separate controllers to like play on. So like that was a pretty cool thing to do. Like it looks complicated, but like when you see it, it's like when you have the things, it's like, oh, okay, like this is kind of, it makes sense. So like, you know, like with doing all of this with Arduino and like computer science and everything, like you would think like, oh, like she had like a ton of like experience doing it before, but like I didn't have like any AP computer science classes at my high school. Like I pretty much came to Berkeley like, okay, I declared CS, but like, do I know CS really? Like, you know, so like, yeah, but this class, like there's just, the number one thing that you have to understand is that don't let like knowledge that you may or may not have from before to like hinder you from what you could really do. Cause like CS10, like Beauty and Joy of Computing, the class that we're doing, like there's so many opportunities here, and like there was just so many people that would help you along the way. And like even if like you kind of suck at doing something and like they would like figure out a problem that you could have like figured out on your own, but you were just too lazy and you were just too irritated to do it, like they would be like, yeah, like you're smart, like you'll figure it out. And like, you know, like just having that like voice in your head and like the voice of people around you, like it inspires you to like do something like this. So, you know, like don't be afraid to like dig deep into engineering. Don't be afraid to like dream big, and like don't be afraid to apply to Cal, because like that's a big thing that people are afraid of. But just like don't, like there's so many people here that are trying to help you and like that could really help you to be like what you want to be in the future. So yeah, that's my thing.
All right, next project.
Hi, my name is Audrey Ma. I'm a freshman student, and my intended major is stats and CS.
I'm Flora Dong. I'm also a first-year student, and my intended major is cognitive science. So this is our midterm project actually. So we coded it about a month ago. It's a game called Flood It, and the ultimate goal of the game is to change the entire board into one color. So you see, you have a random color generator here for a board, and with each game, you have a number of moves. So for that board we had 39 moves. One of our features is that you can change the difficulty of the board. So you can change it from a larger board if you want a more difficult game, or a smaller board. And each board has a set of moves. So if you see in the top right corner, each board game has a given amount of moves, and the moves is how many moves you have for that game, and the counter changes and increases by 1 by every move you make. To play the game, you start at the top, your right corner, and for each of the adjacent squares that are of the same color as the top left corner, you want to change those squares into that color that you choose. So Audrey is trying to change it to red, so you change all those to red, and now next to yellow. The ultimate goal of the game is to complete all the color, the entire board by one color by the given amount of moves, in which you win. But but if you don't do it,
Oh, lol. Okay.
we'll see if she can complete this. I know.
Oh, am I gonna win?
She
okay,
loses, unfortunately. The hardest part of our game wasn't actually the game itself necessarily, but it was finding the code of, can you load another board? Of which blocks to change, which squares to change the color. So we use the process called recursion, which is basically where you use the block itself in the actual code. So basically for this code, it takes the top left corner, which we called it 1, 1, and it checks to the left, to the right, to the top, to the bottom, if it's the same color or not, but if it works. So for example, for the first one, it just checks side and down. And if it does, then it continues going until none of the squares are the same color anymore. So it kind of repeats on itself until until the code no longer works. And yes.
Yeah, so that's basically our midterm project. And so from our previous presentation, you can see that there's a lot of things you can do. In Snap, you can code basically anything you want. And I think that's what's really special about computer science. And so don't be scared to learn computer science, as we both had no prior knowledge of anything really until this class. So I think it's worth a shot to learn in high school and in university.
Thank you.
I know it looks scary. It's not that scary. Hi, I'm Marcus Rice.
And I'm Brendan Wirtz. And for our final project, we did a game called Othello. So we coded it in a programming language called Python, which looks kind of intimidating, but it's not that bad. Okay, so that's how we start the game, and basically the whole point of it is you're placing a spot in a blank position, you're placing your player symbol, so for this one it's going to be an exclamation point, and if there's two of your players surrounding another player, it's going to change everything in between to that player.
I know that may sound really confusing, but see if you put in the coordinate 6, 4, you'll notice on the new board where there was an old hashtag, it's now a exclamation point. So basically our game goes through this over and over until the game ends, when there are no moves left and one player wins, or it could actually end in a tie. So not only can you make moves up and down and to left and right, but you can also make them diagonally. So now you see we put another new hashtag on there, and diagonally in between it changed to a hashtag in the middle.
Exciting. So basically you saw the other two projects, they did theirs in Snap, which we did for most of the CS10 class. And then maybe for a month or so we moved to Python. So the nice thing about computer science that we're basically learning skills. We're not really learning, we're also learning syntax of these languages, which is how to write the code. but the important thing to know is that that's the easy part. The hardest part is like learning the skills to implement ideas in code. And as soon as you do that, you can pretty much apply it to any language that you want.
So the same problem-solving skills that we learned in Snap are definitely applicable to how we made this project in Python, even though the coding is completely different. Or not completely different, but it looks a lot different. So the way that our game actually works is we have this list, which is basically a list of values, and we're printing it every time. So what you're seeing right here is the game board. It's not like some fancy visual or something. It's us telling the computer to print out everything line by line by line. So every little like hyphen, every zero, or exclamation point, or hashtag, or vertical line is something that we told it to print in a very specific order so that it looks like what you see here.
And just like everyone else, we want to add that both of us are first semester freshmen here, so both of us came in having no prior programming experience, and it's like never too late to start. There's this kind of feel maybe at Berkeley that you need to come in, you need to have started like programming since you were 8 years old, but that's not true at all. Like you can start anytime that you want.
So yeah, we, as you said, we both had no like prior experience or knowledge in coding, and then we came in and we've had this success so far. And we really love what the class has taught us, and we hope that we can inspire some of you to look into coding, because it's great for your future, and it's also kind of fun. Like, we put a lot of time into this, and then the moment that it like finally clicks and you get it to all work, it's an amazing feeling to like make something beautiful and have it all work out in the end. So that's our project. Thank you.
You want to introduce yourself? Should we start? Yeah, go ahead.
Hi everyone, I'm Sam. I'm a second year.
Hi, I'm Leandra. I'm a second year also.
Hi, I'm Jenny, and I'm a graduate student here at Berkeley.
And for our final project, we really wanted to create a program that would be super useful to address a problem that a lot of students at Berkeley face, which is being able to choose your classes each semester and choosing from a huge variety of classes. So each semester you really have to decide on what your priorities are. So a few of those priorities could be fulfilling your major requirements, choosing the difficulty of your classes, and how big your class is.
Yeah, so we came up with this idea to create a schedule builder in Snap. And yeah. So are we gonna make it work? Okay, so the way it works is that basically, first of all, you get to define your major in the program. Okay, now we're good. Okay, yeah, so here it is, our schedule builder. And yeah, so like I said, first of all, you get to pick your major. Of course, since this is a CS education day, it's going to be computer science. And then in the second most important step, you actually get to pick your priorities. And so just like Sam mentioned before, that could be whether you want to take classes that mainly fulfill the requirements for your major, or whether you just want to take easy classes or difficult classes, or maybe some of you have a preference of small class size over large class size. And so once you entered your priorities, you also actually get to specify which difficulty level you prefer. And then based on your priorities, it's going to create the schedule. And on top of that, we added a map feature where it actually picks the fastest routes for you to get from one building on campus to the other based on distance and also traffic in terms of other students that also have to walk from the same kind of building to the other one. And yeah, so this is the output. It just draws these cute little maps for you, and yeah. Yeah, and that's the schedule creator.
So
This is like one last thing. I think the cool thing about this class has been that we've learned how to solve problems that are relevant. For example, like the schedule builder, like that's a problem that's relevant for UC Berkeley students. And as a final piece of advice, I think some other people have said this, just don't be intimidated by CS, especially the girls, because I think that there can be a culture that kind of scares people and keeps them from going into CS, but don't be intimidated. So thank you guys for having us.
Cool. Last one, yeah. Do you want me to pull up your code too? Or so that's your code.
Hi, I'm Sophie. I'm a freshman, and yeah.
And yeah.
Hi, I'm Donby. I'm the weirdo here. I'm a senior.
So our project is called the synesthezer, and it's based on a concept called synesthesia, which is sort of where your senses get mixed up. And so, unfortunately, you can't really have taste or smell in computer programs yet. So we combined sound and sight. So you can make a drawing and then hear what it sounds like. So like the x-axis is sort of time, so rhythm, and then the y-axis is frequency or like pitch. So.
And since you can also take multiple perspectives on the same object or event in life, we made it so that you could read it in 4 directions. So you can read the same photo from left to right, right to left, up, and then down. So we'll do a little demonstration. Since our code isn't actually working, we're gonna show you part of our video.
Well, it does work. It just doesn't work on this
Isn't
laptop
read on this
right
computer.
now.
So we're gonna show you our video demonstration that we made.
This is a demonstration of the synthesizer's multi-way reading capability. I will demonstrate with a simple diagonal line. Can they hear it? To read the file from left to right, you press the right arrow. To read the file in reverse, from right to left, you press the left arrow.
And it would also read from down, up, and then up, down, if you so choose to do that. So if you take a look at our, where's our code? There you go. If you take a look at our code, we're we're sort of checking for all of these different events. So we're checking for the mouse clicking, and we're checking for different keys clicking. And then we have a way to sort of sort the coordinates that you clicked so that we know which frequencies to play based on which arrow key you pressed.
Okay, I don't have much more to say about this code other than that it took many hours and I almost cried, but we did it. And I would not be here today like knowing code if I did not learn with my partner Sophie. She's a freshman and she taught me more than I could teach her as a senior. So since I can't say much about coding, I'm gonna say something about life experience since I have a little bit more of that. So yes, computer science is basically a new language that you're gonna learn. It's either gonna empower you or it's gonna make you feel like you don't know anything, because computer science is basically a reflection of what you have going on inside. It's gonna give you these tools and it's gonna say, make whatever you want. And so I hope that you guys will make something good out of it, something that will help the world, hopefully. That is my dream with my little science coding, project. I don't know if it did much, but I hope I can inspire you guys. Just do it. Do whatever makes you be the greatest version of you. And I want you to say your previous coding experience.
So I actually had a very small amount of coding experience. I went to this summer program called Girls Who Code, which if you're a girl and you're interested in coding, it's a great way to get a taste during the summer. But this class really helped me get like a deeper understanding of how to actually think like a computer scientist and really solve problems no matter what coding language you're using, which I think is really sort of the best thing about this class.
Thank you, guys. So we have a 10-minute break. You can feel free to stand up and stretch and do what you want. But be back here in 8 minutes.